Your AI agent just shipped a hotel recommendation 90 minutes from the venue, and there is no way to catch the mistake. The loop and critic pattern stops there. Over the next 5 minutes, you will see how it works, how to wire it up, and the exit condition design that decides whether the iteration held or just burn the tokens. Single pass agent have a blind spot. They generate once and then they ship. No validation, no feedback, no second chance. When your output has satisfy hard constraints, such as like in our case, hotel within the 30 minutes, budget under $1,000, dietary restrictions to be met, maybe the one pass is not enough. You will need generate, validate, and refine loop. Let's understand using a very simple example. You ask for a trip plan, San Francisco hotel within the 30 minutes of the venue. The kind of a specific constraint is exactly why this pattern exists. A single pass agent, it will miss it more often than you expect. The generator agent produced the initial itinerary. Here is the thing, the first pass is expected to be imperfect, and that's the whole point. The loop exists because the first draft sometimes do not nail all the constraint at all go. Critic agent then checks and draft again the explicit criteria. Hotel proximity, dining quality, transfer feasibility in our case here. If anything fails, it sends back specific actionable feedback, and that's critical area. Actionable feedback, not the wait response like try again. The critique becomes the context for the next generator call, and the generator instruction uses the methods to inject the feedback only when it exists. That's a conditional injection, and that's a wiring detail that makes loop actually work. Once all constraints pass, the critic will approve the plan and it will be out of the agent loop. Without that exit condition, the loop may run forever. So your safety net is a max iteration. Alternate safety when also put at the max token, but there is a sensible default to have either of them or both of them. Before we get into the trade-off, let's understand and run using a real-world example. So I'm going on a VS Studio Code now, and my server is running here, which has all the agents as I anticipate. And what we got there is a client which we call. So I took a liberty to run the client, and it actually worked in a first response itself. So the first response was correct. Now let's see and try our luck to see if we got in a first response. Well, this time it might take 2 or 3 times. For this example, we are learning a local OLAMA with the very entry level Quen 3.5 0.8 billion parameter model. So the quality of a response is not here our assessment. We want to validate the pattern itself. So here we can see the first iteration is going, and we were lucky this time also it passed on the first iteration. Let me run again and see. It may take 2 or 3 iterations randomly because I have added the random failures. So let's see if we are lucky enough and get a 1 failure now. We've been again luckily unlucky because it's again passed on the first iteration. So I'm just gonna do one other go and see if it works. It's surprising that we are wishing to fail, so we can demonstrate here. But if it doesn't, then just let's assume it and we'll move on. Well, here it fails, so you can see the critic response here given. This is just a brief of the critic response, but internally it provided a very detailed response, and critic requested the improvement and the looping. And now we got a second iteration is running on it. Let's see, the second iteration passed and we got our feedback assessed, everything. So this is how it works. Let's go back on the trade-off. So here we are on the trade-off. Each iteration cost 1 generator call plus 1 critic call. 2 iteration, double the token, 3 triple. Maybe not literally, but in that pretty much level. But the quality game is real with this. For some of the very important business processes, this is a very lifesaver pattern and should be mastered by all. Most improvement land most likely in her first 2 iterations. Some of the complex requirements may take more iterations as is needed. After that, you will hit the diminishing return. So it's very important to find out the point where you start getting a diminishing return, and that's your likely a candidate for the maximum iterations. So make sure you collect the quality metrics to justify cost as well, because this could run into the higher cost pattern, one of the higher cost patterns certainly. Loop and Critic gives you agent pipeline the ability to self-correct. Your exit condition decides whether you get the quality improvement or cost rectification. So design it carefully, cap your iterations and measure the gain. We are good with now 6 methods that we already covered in last 6 videos. In next videos, we will try to implement some real world example and try to see that how we can actually put these methods together in one or many combinations and see what can be done with this. Most likely, in my experience, by understanding this 6 pattern and mastering this 6 pattern, in most cases, person would not require to go to some other advanced patterns as well. However, there are some other advanced patterns that would be useful as well. But in most of the enterprise cases, this should be sufficiently enough to cover the ground that we anticipate. So I'll see you in the next video. Make sure you keep subscribed and like our channel to make sure the next videos come in your inbox or a notification list. Thank you, and I'll see you again in the next video.